Question 3.28. What potential difference is needed to give an alpha particle composed of two protons and two neutrons 200 kilo electron volt of kinetic energy? So here in this question you have an alpha particle that has a charge of 2 proton. So we write Q equals 2 times E, where E is the elementary charge on proton and electrons. Neutrons are neutral particles, so we do not need to consider any charge for them. We need to find what potential difference is needed for this alpha particle to have a kinetic energy of 200 kilo electron volt. Now 1 electron volt is equivalent to 1.602 times 10 to the power negative 19 joule. So I can convert this kinetic energy in electron volt to joule by multiplying with this number. So we write kinetic energy of alpha particle to be equal to 200. Kilo means 1000, so we multiply 200 with 10 to the power 3. And electron volt will be 1.602 times 10 to the power negative 19 joule. So this is the kinetic energy of alpha particle. We need to find the potential difference delta V. We know that work done and kinetic energy are related by the expression work done W is equal to change in kinetic energy. And work done can also be written as negative of potential energy, which is equal to delta K. Potential difference delta V is related to change in potential energy as delta V equals delta U over Q. So we can rearrange this term to write for delta U as Q times delta V. Substitute this here, so we get negative Q delta V equals delta K. We need to find the potential difference delta V, so divide with negative Q on both sides. Delta V will be equal to delta K over negative Q. Change in kinetic energy is nothing but the kinetic energy gained by the alpha particle, which is given here as 200 kilo electron volt. And charge on the alpha particle is 2 times E. Let's substitute. I write K as 200 times 10 to the power 3 times 1.602 times 10 to the power negative 19 over minus 2 times E. E is the elementary charge on electron and proton, which is 1.602 times 10 to the power negative 19. And when you solve this, you get the change in potential to be equal to negative 100 times 10 to the power 3 volt, which you can write as negative 100 kilovolt. So this is the potential difference needed for the alpha particle to gain a kinetic energy of 200 kilo electron volt.